Dear students, welcome to Mathematics Online classes. In this class, we will study the concept of vector or cross product of two vectors. One type of product is already got over, that is dot product of two vectors. Dot product or scalar product of two vectors, that is A dot B is equal to magnitude of vector A into magnitude of vector B into cos theta. That concept has got over with the previous video. In this video, next product of two vectors, that is cross product of two vectors. See, what is the definition says? Definition of cross product of two vectors. If A and B are two vectors, if A and B are two vectors, cross product of A and B denoted by A cross B is defined as A cross B is equal to magnitude of vector A into magnitude of vector B into sin theta into n cap. I will explain what are the notations used here. A cross B, cross product of vector A and vector B, it will be denoted like this, A cross B. It is defined as magnitude of vector A into magnitude of vector B into sin theta. What is this magnitude of vector A? Magnitude of vector A in the sense length of vector A, it will be taken. Let us take, this is first vector and there is another vector, that is vector B. Its magnitude is taken, means its length is taken. Now here theta is the angle between vector A and vector B. So A cross B is equal to magnitude of vector A into magnitude of vector B into sin theta into n cap. See, magnitude of vector A into magnitude of vector B into sin theta is the magnitude or length of A cross B. Length of A cross B. What does this n cap indicate? N cap indicate direction of A cross B. That means A cross B is a scalar or vector. A cross B is a vector. It has the magnitude. That is magnitude of vector A into magnitude of vector B into sin theta is in the direction of n cap. I will explain you what is n cap. N cap is a unit vector which is perpendicular to both vector A and vector B. Suppose vector A and vector B are lying on a plane like this. If A and B are lying on a plane, then n cap will be perpendicular to both A and B. Suppose these two are A and B. These two are vector A and vector B. Here will be n cap. This n cap is perpendicular to both A and B. Now it will be here. This is n cap. What does this indicate? N cap indicate a unit vector which is perpendicular to both A and B. So A cross B has a magnitude of vector A into magnitude of vector B into sin theta and it has the direction of n cap. This is A cross B. Suppose I take B cross A, what happens? If I take B cross A, again it will be magnitude of vector A into magnitude of vector B into sin theta, but its direction will be opposite to that of n cap. So it will be written as a minus of n cap. Where this minus of n cap will be? Minus of n cap will be here. This is minus of vector n cap. I will explain you this n cap with examples. See, this is a screw written here, x, y, x axis, y axis and z axis in a 3-dimensional plane. Here is a xy plane. In the direction of z axis, we have written a screw diagram over there. See, we know that if x and y are acting on the plane, means if a screwdriver is working like this here, in one direction it is moving, in the sense it is on the xy plane, then this screw will be moving up. See, x and y, if it is working like this, it will be moving in the z axis. That means if A and B are working here, according to the right-handed system also we can explain this. If A cross B is working here, then this n cap will be going up. Suppose we take opposite direction. B cross A, if we take, it moves in the opposite direction. As here we know that if you are tightening the screw, it will be moving inside the wall. If you move it in the backward direction, means if you rotate it in the opposite direction, it comes back, it comes out of the wall while tightening the screw. That is the concept of cross product of two vectors here. See, in the same way here, if x in the xy plane, if screwdriver is working like this, it will be moving up. If you move it back, if you rotate it back, it comes down. That means it comes in the direction of minus n cap. That is one kind of example. Let me explain in another way if you are not understanding well. See, suppose we are tightening a bolt. If suppose you are tightening a bolt, we need two spanners over there. Two spanners we will be holding. Let us take two spanners are like this. We are holding. One is fixed one, another one will be, we will be rotating it. Here is the bolt. If you rotate it in one direction, this is one tighted one. If you rotate it in the one direction, if you rotate in the anti-clockwise direction, this bolt will be moving up. If you rotate it back, it will move down. That means the bolt which is moving, it will be having the magnitude, it will be having the length of magnitude of vector A into magnitude of vector B into sin theta. What is theta? Theta is the angle between these two vectors. That means these two spanners. Okay, it will be having its magnitude. And which direction it is? The direction will be deadly, means it will be completely perpendicular to both the vectors which are acting. Spanners will be acting like this. Those will be on a single plane, and bolt will be completely perpendicular to it. That means it will be perpendicular to both first vector and the second vector, both the spanners, it will be perpendicular. And if you rotate it backward direction, where that bolt will move down, in the sense bolt will go in minus n cap direction. So very simple it is, very simple. If A and B are two vectors, then cross product of vector A and B is denoted as A cross B, and it is defined as A cross B is equal to magnitude of vector A into magnitude of vector B into sin theta. It is in the direction of n cap, and B cross A will be directly opposite to that. What about its magnitude? Magnitude will be same. If it is written like this, magnitude of A cross B, this will be magnitude of A cross B. Magnitude of A cross B is equal to magnitude of vector A into magnitude of vector B into sin theta. We should write only this much. If vector is written, vector n cap minus n cap, that should be there. Okay, now let us go to the next one, that is observations on cross product of two vectors. Here we know the definition of cross product of vector A and vector B. A cross B is equal to magnitude of vector A into magnitude of vector B into sin theta in the direction of n cap. N cap is perpendicular to both vector A and vector B. We know this. Now what are the observations here? First observation is that A cross B is a vector quantity. It is having both a magnitude and a direction. A dot B we have studied. A dot B was a scalar quantity, but A cross B is a vector quantity. It has both magnitude and a direction. That is the first observation. Now second observation is that if vector A and vector A is not equal to 0 and vector B is also not equal to 0 vector, then is there any other possibility of A cross B is equal to 0? Yes, if vector A is equal to 0 vector and vector B is not equal to 0 vector, we have A cross B is equal to null vector only when A is parallel to vector A is parallel to vector B. How is this? See, we know that A cross B is equal to vector A into vector B into sin theta. If theta is 0 degree in the sense A and B are not at all intersecting, A and B both are parallel to each other. In that case, theta will be 0. As theta is 0, so we will be having A cross B is equal to 0. We can write here, if A cross B is equal to null vector, this implies vector A is parallel to vector B. This is the observation we are seeing here. And next, if either A is equal to 0 or vector B is equal to 0, then automatically A cross B will be 0. Even if it is 180 degree also, means if vector A is in one direction and vector B is in deadly opposite to it, so angle between them will be 180 degree. In that case also what happens? In that case also cross product of these two vectors will be 0, because theta is equal to 180 degree, that is 0, sin 180 is 0. So A cross B is equal to 0. This is the second observation. And what about the theta value here? Theta can take the values 0 to pi, 0 less than or equal to theta, less than or equal to pi, 0 to 180 degree it can take. Now suppose here theta is equal to 90 degree, what happens? If theta is equal to 90 degree, then A cross B is equal to sin 90 is 1. This will be magnitude of vector A into magnitude of vector B into, that is n cap. And if you take magnitude here, magnitude of A cross B, if theta is equal to 90 degree, then this will be magnitude of vector A into magnitude of vector B it is. Okay. This is the second observation. Now, going to third observation. This is very important one. Third observation. See, what is the cross product of unit vectors? That concept we are studying under this observation. Cross product of unit vectors. What are the unit vectors? I cap, j cap and k cap. Unit vector along the x axis, unit vector along the y axis and unit vector along the z axis. I, j, k. What will be I cross j? What happens to this? I cross j will be, see, I will be in the x axis, this is I axis, I, and this is y, in the sense here will be j. Where will be k? K will be along the z axis, this will be k. See, I cross k, I cross j we are taking. I cross j will be like this. I cross j will be acting on the xy plane. Where it is projected? It should move in the z axis. So, let us not confuse with this diagram. What you do? We will go with the definition. What is I cross j? I cross j is equal to magnitude of vector I, magnitude of vector j into sin theta into n cap. See, magnitude of I is, it is unit vector 1, magnitude of j unit vector 1 into sin. What is the angle between I and j? As I told you in the diagram, x axis and y axis will be perpendicular to each other, that means sin 90 degree here. What is n cap? N cap, that will be perpendicular to both x axis and y axis. The axis which is perpendicular to both x axis and y axis is z axis. Z axis unit vector along the z axis will be k cap. Sin 90 is 1. So this is k cap. What is I cross j? I cross j is k cap. I hope you are understanding. In the same way, what will be j cross k? what will be j cross k. J cross k. See, j cross k. Let me write the diagram once again. This is x axis, this is y axis, this is z axis. All are perpendicular to each other. J cross k in the sense, here will be j and here will be k. Both are perpendicular to each other, and product of these two will be in which plane? Means along the which direction? It will be along the x axis. Somewhere here it will be j cross k. I can go with the definition also. Magnitude of j, magnitude of k into how much is the sin 90? Angle between y axis and z axis is 90 degrees. Sin 90 into n cap. This is one only. N cap will be I cap. It is along the x axis. J cross k is equal to I cap. And in the same way, what will be the k cross I? K cross I will be j. K cross I. And this will be j cap. How to remember it very easily? How to remember it easily in the sense? See, you remember one circle here in the anti-clockwise direction. A circle is rotating like this in the anti-clockwise direction. You take it as I, j and k. See, I cross j is k. I cross j is k in the anti-clockwise direction. Next, j cross k. J cross k is equal to next is I cap, and k cross I is next j cap. Simple. And instead of that, what will be the j cross I then? J cross I will be minus k, because it goes in the opposite direction. With the same diagram we can take. If we are going in the anti-clockwise direction, I cross j, next will be k. If we are coming in the clockwise direction, j cross I, then it goes with the minus k. According to the definition, it goes in the opposite direction. Okay, j cross j. In the same way, what will be this k cross j? K cross j is minus I cap, and this I cross k is equal to minus j cap. Okay, I cross j and j cross k we take. Suppose there is I cross I, j cross j and k cross k. What happens to it? I cross I is there. I cross I is there. What happens to it? Let me see according to the definition. I cross I is equal to magnitude of I into magnitude of I into sin theta. What will be the sin theta? It will be sin 0 degree into n cube. Sin 0 value is 0. So, this will be a null vector. In the same way, j cross j is null vector. K cross k is also a null vector. I cross I is null vector. J cross j is equal to null vector. K cross k is equal to null vector. Very simple one. This is the third observation. Now let us go with the next fourth observation. Can we find out angle between two vectors using this? Yes, we can find out angle between these two vectors using the formula, that is a cross b is equal to, we know that magnitude of vector a into magnitude of vector b into sin theta in the direction of n cap. See, instead of taking a cross b as a vector, let us find out its magnitude. What will be the magnitude of a cross b? Magnitude of a cross b is equal to magnitude of vector a into magnitude of vector b into sin theta. That's all. Its magnitude. Can't we separate theta from this? Easily we can separate it. Now here sin theta is equal to magnitude of a cross b divided by magnitude of vector a into magnitude of vector b. So, using this formula we can find out angle between two vectors. But if they ask you to find out the angle between two vectors, better to use the dot product, because dot product will be easy compared to cross product. A cross b we need to find out, a cross b in the component form. A cross b in the component form will be difficult. I will tell you that. It is not the difficult part. It is somewhat difficult compared to the A dot B. Finding A dot B of component form of two vectors is very easy compared to this. That's why I am saying. Now, let us go with the next observation, fifth observation, that is okay. If A and B represent adjacent sides of a parallelogram, if A and B represent adjacent sides of a, before going to the parallelogram, let us go with triangle first. If A and B represent adjacent sides of a triangle, then very important one it is. There are many problems on this. If A and B represent adjacent sides of a triangle, then area of triangle is equal to half into magnitude of A cross B. Half into magnitude of A cross B. This one you should remember. I will prove how this. See, I will consider a triangle. Let us consider a triangle like this. A, B, C are the vertices of the triangle. Then to find its area, we need base and height. Let us draw perpendicular from the vertex A to the opposite side BC, and let me name this as AD. AD is perpendicular to BC here. And suppose vector A and B are adjacent sides, So let me take AB as vector A and BC as vector B. I am taking AB side as vector A and BC side as vector B. I am taking here. Now, area of triangle is equal to what do we know the formula for area of triangle? That is half into base into height. Half into, what is base here? Base is BC, height is AD. Now half into, what is base? Base is BC, means BC is represented as vector B. What will be its length? Its length will be magnitude of vector B. So here you write magnitude of vector B, and then into AD. Let me write one more step. AD is equal to, what is AD here? See, A and B representing the adjacent sides, let me take angle between these two will be theta only. According to the definition, angle between vector A and vector B which are acting at a point, that angle will be taken as theta. Okay, this is theta. Now, we will use sin theta here. Sin theta is equal to, in triangle ADB, AB is hypotenuse because this is 90 degree, and here is theta acute angle. AD will be the opposite side, BD will be the adjacent side. Sin theta is equal to opposite side by hypotenuse. This is AD by hypotenuse is AB. Okay, what I can write for AD? AD is equal to, I can write AB into sin theta. AB is length of side AB. Length of side AB can also be written using the vectors as magnitude of vector A. Magnitude of vector A into sin theta. What is this? This is AD is equal to. Now here I have 1 by 2 into magnitude of vector B. AD is magnitude of vector A into sin theta. See, it can be written as half into magnitude of vector A into magnitude of vector B into sin theta. Just I am interchanging these two, no problem. Now we have this is equal to, let me write it here only, half into, what is this? Magnitude of vector A into magnitude of vector B into sin theta. That is nothing but magnitude of A cross B. So this is magnitude of A cross B. Okay, now we have proved area of a triangle whose adjacent sides are represented by vector A and vector B is half into magnitude of A cross B. Now, one more observation is there, that is sixth one. Sixth one, if vector A and vector B represent, if A and B represent adjacent sides of a parallelogram, adjacent sides of a parallelogram, then area of parallelogram, then area of parallelogram is given by magnitude of A cross B. Very easy to remember. Area of triangle whose adjacent sides are represented by A and B is half into magnitude of A cross B. Here it is just directly magnitude of A cross B. Okay. There is a parallelogram like this. Parallelogram I have. Let me represent it vertices as A, B, C, D. What is the area of parallelogram? Area of parallelogram is equal to length into breadth. Length into breadth. See, I will take this height like this. Now A, C, D, I will take it as E. It is nothing but base AB into height D. AB into D. And A and B represent adjacent sides of a parallelogram. Let me take AB and AD are the adjacent sides. AB, let us take, it is representing by vector A. AD, let us take, it is representing by vector B. And theta is the angle between AB and AD. This is height of the parallelogram, you know. This has to be the perpendicular length. DE is perpendicular to AB. Okay. Now, area of parallelogram is equal to, what is AB? AB is represented by vector A. Its length will be written as magnitude of vector A. Let us write DE as it is. Now, DE. See, in the triangle AED, in the triangle AED, E is 90 degree means AD will be the hypotenuse. Theta is here, means theta at the vertex A. AE will be the adjacent side, DE will be the opposite side. So, in triangle AED, we have sin theta is equal to opposite side DE by hypotenuse AD. So, we have DE is equal to AD into sin theta. What is AD? AD is magnitude of vector B. Magnitude of vector B into sin theta. Okay. This is magnitude of vector A. D is magnitude of vector B into sin theta. Again you see, what is this magnitude of vector A into magnitude of vector B into sin theta? That is length of A cross B or magnitude of A cross B. So, magnitude of A cross B. What is this? This is area of a parallelogram where vector A and vector B are adjacent sides of parallelogram. That is important. Vector A and vector B are representing adjacent sides of a parallelogram. You should not take opposite sides and all. Okay. These are the observations about cross product of two vectors. Now, one small heading we will take, that is distributive property of cross product of two vectors. Distributive property. See, first one I am saying, if A, B and C are any three vectors, there is no proof for this, just you know it, how it works. A, B, C and A are any three vectors, then suppose we have A cross B plus C, A cross product with a vector B plus vector C, or we can take it like this also, A cross B minus C, no problem, that is plus or minus we can take, or instead of like it is like a plus r minus b, which is in cross product with the c, like this is it is there everything. Distributive property, first it will be cross product is distributive over addition of vectors, cross product is distributive over subtraction of vectors. Here I can write it is a cross b plus a cross c. Here also same way, a cross b minus of a will take the cross product with next, that is a cross c. In the same way here, a cross c, a cross c, here plus is there, right, plus into again b cross c. That means cross product is distributive. And the second one is that if a and b are two vectors, if a and b are two vectors and lambda is a scalar, suppose we have lambda into a cross b, lambda into a cross b is there. Here this lambda can be multiplied with vector a or this can be multiplied with vector b, no changes in the value. So this is lambda into vector a, which will be in cross product with vector b, or this can also be written as vector a is in cross product with the lambda times vector b. So these two are the distributive properties of cross product of two vectors. Thank you. In the next class we will take problems on cross product of two vectors.